In the last episode, we talked about epigenetics, the way environment can flip genetic switches on or off. Today, we are going to talk about the hormonal world of obesity and dive even deeper. Here's the truth. Obesity is not just about food and calories. It's about a highly complex network of hormones and signals, your body's internal messaging system that tells you when to eat, when to stop, and how much energy to burn. And when that system gets disrupted, the consequences ripple through your entire body. So that brings me to the first concept, the food and hormonal disruption. Let's start with highly processed food. Modern ultra-processed foods, think fast food, sugary snacks, packaged meals, they don't just give us excess calories, they actually disrupt our neurohormonal pathway. These pathways are the communication lines between your brain, your gut, your fat tissue, and other organs. They regulate hunger, they regulate satiety. Satiety is the feeling of fullness, metabolism, fat storage, and distribution. When those pathways are thrown off balance, it becomes much harder to regulate weight, no matter how disciplined you are. This is why it is so important to understand. I want to go over the key hormones that are the major players in these pathways. The number one is leptin. It is produced by fat cells, our adipose tissue. It normally tells our brain we have got enough energy stored, you can stop eating. But in obesity, leptin signaling often gets blunted, leading to leptin resistance. Your brain thinks you're starving even when you're not. This brings me to the next hormone, ghrelin, often called the hunger hormone. Ghrelin rises before meals and makes you want to eat. After weight loss, ghrelin often spikes higher, driving hunger and making weight regain more likely. This is also the reason your hunger and cravings go up when you're trying to lose weight. Our body doesn't understand our goals or desire to lose weight. It equates us limiting our calories to lack of food or starvation or famine. Our primitive brain is designed to keep us out of danger. So what does it do? It increases hunger. It revs up your cravings from the activation of reward pathways in the brain. We'll discuss more about this when we discuss why GLP medications have been so successful. The next hormone is insulin. It regulates blood sugar. But when the body becomes insulin resistant, more insulin is secreted, which in turn promotes fat storage. I'll explain this more in another episode. Next hormone is cortisol, the stress hormone. Chronic stress and high cortisol levels can drive overeating, fat accumulation, typically around the belly, and metabolic dysfunction. Together, these hormones form a tug-of-war that's incredibly difficult to win when the system is out of balance. The next concept here is the body's feedback loops. Here's something important to understand. When you lose weight, your body fights back. Hunger increases, energy expenditure decreases, metabolism slows down, and the weight starts going up. Why? Because your body views weight loss as a threat to survival. This is part of the feedback regulation that I was talking about initially. Let's talk about the body's feedback regulation system. The signals from muscles, the liver, bones, and fat tissue carried by molecules called cytokines constantly update the brain on your energy status. The fat tissue is an endocrine organ. It's not just a blob of tissue or a cushiony material that occupies space in your body. It's an active endocrine organ. It produces adipokines, which are a kind of cytokines that are also hormonal and have role in inflammation. Fat, being an active organ, one of the largest endocrine organs in the body, produces about 600 signaling proteins called adipokines. Some of the big ones include leptin that we just talked about, which is a regulating hormone of your appetite and energy stores. Some of the other ones are adiponectin, which improves insulin sensitivity. It regulates metabolism and inflammation. Then there is resistin, which is linked to insulin resistance, and TNF-alpha, which drives inflammation. These adipokines influence everything from appetite regulation, insulin sensitivity, and inflammation that drives the development of all chronic diseases like heart disease, diabetes, and even cancer. So when fat mass increases, it's not just extra weight. It is a hormonal storm reshaping your metabolism and overall health. In conclusion, this adds on to the understanding of how genetics set the stage, the environment influences with epigenetic changes from the environment that pull the trigger, but the final common pathway is the elevated fat mass and disrupted neurohormonal signaling. The final common pathway is elevated fat mass and disrupted neurohormonal signaling. This is why weight gain is so challenging, because your body is actively trying to resist weight loss. And it's also why treatments that target hormones, whether through lifestyle medications or even surgery, are so important. In the next episode, we'll explore leptin a little bit more in detail. Thank you.